Okay, so we're talking about electromagnetic interference and how it is a problem for copper as a medium, right? Umuma industrial areas, mninge mukurira electric motors and all sorts of electrical signals all over the place. Copper is not ideal for those environments because of that electromagnetic interference. You won't get a clear signal because of that. Right, mitigation. How do we prevent against that? Strict adherence to cable lengths limits will mitigate attenuation. Right, if you follow my standards, ma-organizations akaita se-EIA anenge akatotaura kuti Ethernet cable kada kushandisa for more than 100 meters. That's a problem. You experience some losses. Standards. So you need to stick to that. Cable length, some kind of copper cable mitigate EMI and RFI by using metallic shielding and grounding. So for my copper cables here, we can have shielding that could limit the interference. Some kinds of copper cabling, uh, some kinds of copper cabling mitigate crosstalk by twisting opposing circuit pair wires together. We'll talk about this crosstalk and twisting of crosstalk and twisting of opposing circuit pairs. This one we'll talk about in the next slides. So basically, you can see we can minimize the attenuation. For example, the losses. Attenuation, we use minimum cable length. We can use shields so that we can reduce the electromagnetic interference. But the goal, kana tiri kuda communication iri proper chayo, we just use fiber. All of the choice now, the choice will be dependent on the cost. Number one, as an engineer myself, one of the first things I think when I'm designing anything is the cost. So can I copper cost, let me add, plus effectiveness. Not only cost, but effectiveness of whatever I'm designing. Here in this case, communication. So if copper is inexpensive, as they say, then I'll use copper. But at some point, if it is not that effective, I'm experiencing some losses, then I'll probably need to consider this fiber, which is expensive, depending on a couple of factors, which we are going to discuss, I think, in later slides. Right, types of copper cabling that we have what we call UTP, unshielded twisted pair. Then we have shielded twisted pair, and lastly, coaxial cable. We're going to look at all those cables one by one. UTP, most common in networking media, terminated by RJ45, interconnects host with intermediary network devices. So if you are connected to the internet using an Ethernet cable, that Ethernet cable is definitely made of this type of cable that we call UTP. Key characteristics, it is an outer jacket, number one. This outer jacket that protects the copper from physical damage. Number two, we have twisted pair to protect signals from interference, crosstalk. All right, we have number three, color-coded plastic installations. Insulation electrically isolates the wires from each other and identifies each pair. Color-coded so you can be able to recognize permanent connections, especially with the connector RJ45. There's a specific standard that we use to make those connections. You know, because of my colors. That's why they are color coded like that. Right. I think it's also time we discuss what crosstalk is and why those wires are twisted, because that's a typical exam question. Crosstalk, right? It occurs when signals from one wire interfere with signals from another wire. So if you have two wires like this, There is an electromagnetic wave that is created along this wire. Electromagnetism. There is another electromagnetic wave that is created along this wire. If these waves interact, that's a problem. These two waves can interact. Probably anosangana pakati apo. That's a problem because they create distortion, mass signals. That is interference. So what do we do to prevent that? That is what we call crosstalk. What do we do to prevent that? We twist my wires. If these wires are twisted, that interference is cancelled because of twisting of those wires. So we've defined what crosstalk is and how we mitigate that. We twist my wires. So if the question comes, why are those wires being twisted? Is to reduce what we call crosstalk. Right, shielded twisted pair, UTP is the same as STP. I don't want to say the same. STP is UTP plus shield, basically. It has a shield, that extra protection, right? Which shields from, for example, which prevents electromagnetic interference. So STP shielded. I think the name says it for itself. Better noise protection. Why? Because of the shields. More expensive. Why? Because of the shield. Harder to install because of the shield. Termination is still the same. Their use is still the same. Key characteristics, number one, the outer jackets, which protects from physical damage. We have the shield, which provides protection against the interference, electromagnetic and radio. We have number three, the foil shield for each pair of wires protected provides another layer of protection. So we have this shield, number two. We also have shield on the wires, number three. The cost is too much. When I'm designing which type of cable do I need to use, it depends on the cost and effectiveness. Kana ndiri kugadzira cable yekuti ndiconnect to the internet at my house, there is no need to use STP. Why? Probably I'm connecting short distances. Kumba kwangu, there is not much electromagnetic interference. There is no need to use this. But if I'm in an industrial area, for example, there's definitely need for STP because of the electromagnetic interference. So the cost zofambidzana ne-effectiveness of the communication that we need. Right, coaxial cable, all I can say about this cable, kana mune satellite dish, there is definitely a coaxial cable there. Kana mune satellite dish, that connection to the LNB and kuseri decoder. I think it's this one. It should be. No, it should be this one. F-type. I'm not so sure. But if you go to your satellite dish, you definitely see something like this. And that is the coaxial cable I know. Anyone in chat, F-type. It's the F-type. Yeah, this one. I'm not that technical with coaxial cable. If you go to satellite, go decoder range, there's that cable. And there's a cable I saw. Right, the coaxial cable, that's another example of copper cabling. The outer jacket, we have the outer jacket, the metallic foil, we have a layer of flexible plastic installation. Number three, number four, the conductor. So number four, that is the copper conductor there. Types of connectors that we have with UTP and STP, you can see we mainly focus on the RJ45. This needs to be stuck in your head. The RJ45 is the connector for UTP and STP. Now, when you talk of coaxial cable, we have BNC, N-type, F-type. Commonly used in the following situations: wireless installations, attach antennas to wireless devices, cable internet installations, customer premises wiring. The most common application antenna decoder connection. You see that coaxial cable cabling, right? UTP, basically UTP, we have four pairs akatwistwa. Why are they being twisted? To avoid crosstalk cancellation. Each wire in a pair of wires uses opposite polarity. One wire is negative, the other wire is positive. They are twisted together and the magnetic fields effectively cancel each other and outside electromagnetic interference. Let's stop with effectively cancel each other. So we twist the wires so that we don't have that field that is created by the electromagnetic waves. With UTP, no shielding is used, not much here. UTP cabling. Standards for UTP are established by TIA. There goes the organization. We have already introduced that organization. So all the standards that we have, they're defined by the standard that we have for UTP cabling. They're defined by this organization. So they define the cable type that we're going to have, the length of the cables, the type of connectors that we're going to use, the type of cable terminations that we're going to use, and also the testing methods that we're going to have. Electrical standards for copper cabling are established by the IEEE. That's another organization which rates the cable according to its performance. Cable yako kana Cat 3. I think this is 10 megabytes per second. Cable yako, if it has the capacity, you can transmit at most 10 megabytes per second. Think it through it Cat 3. So depending on capacity yainayo, those are the standards which are defined by IEEE. Kana iri pa 100 megabytes per second, inenge runzi category 5. Kana yapa 1 gig, yakunzi category 5E. Kana yapa 10 gig, yakunzi category C. So in terms of applications, you see the most used in 100 megabytes. For home use, even office use, small office use, we can use that. 100 megabytes per second capacity, that's huge. That's a lot, right? Then huge companies, enterprise networks, critical links, they use this one, Cat 6, 10 gigabytes per second. That's a lot of traffic there, 10 gigabytes per second. We also have Cat 3, we don't have 4. We also have 6A, 7, and 8, with speeds getting up to 40 gigabytes per second. I think the 8th one is 40 gigabytes per second. The choice of the cable depends on the specific requirements of the network, the speed that you need, the environment, and the budget. With the environment, I think I talked about home use. Environment yekumba, there is not much interference. Environment here, industry, a lot of interference. Therefore, we need a standard rakati simbe. And the difference, what differentiates those standards? If you look at cable irape, right, tine twisted pair yedu, yeah, they didn't demonstrate it well, but twisted pair actual, how do I say it? In my twist mashoma, let me put it that way. My twist, and category 3 up, mashoma, meaning interference in iripo small, ye crosstalk. Tikayapa Cat 5 up, my twist anenge akawanda per length, if I can say. My twist anenge akawanda, and you can see they are very visible. Panapa everything straight, but it's not supposed to be straight. It's twisted, but the twists per length, they are not that much. Category 5, my twist awanda. It means less crosstalk. Less crosstalk, more bandwidth. Less losses, more bandwidth. Mukatasa category 6 hiyo, you can visibly see pane shield aripapo. There's a shield ripple. Shield zero, it means less losses near electromagnetic interference. Therefore, my speeds or the capacity of that cable increases. So the difference between my cables are category 3, category 5, category 6. inotangira in the way they are made. Anogadzirwa sei. And that leads to the different speeds that we have here. Iyo nemugadziriro wayo is very cheap. Iyi nemugadziriro wayo a bit expensive for critical applications. Right, connectors RJ45. Next time we meet guys coming in, I think this is one of the things that we will need to do. Kugadzira ma cables which are used for my connections in home networks using the RJ45 connector. Right? Very easy to make. We're going to make a cable like this one. This one is poorly made. Why? It exposes my wires is poorly terminated. Inongonongos sotoka. Mukati umu, probably the connections are not very good. You can see the difference with this one. You can see those wires because it's connected properly. So when we come for the next labs, I think one of the things that we're going to do, we're going to terminate my UTP cables using my RJ45 connectors. Right, straight through, what's written here? For satellites, yes. Straight through and crossover cables. Right. So with UTP, we have two types of cables, mainly two types of cables that we can make with UTP, depending on the standards that we are going to be using. We have two standards that defines the type of cable that we can have UTP. We have this standard T568A, 568B. Depending on the pairs that we have and the color codes that we have, we can either make a standard A or a standard B. So with standard A, you can see my pairs are rooted on green, green, no. Right, you can see my pairs, pair 3, pair 2, pair 1. How do I put this? Just a minute. It's very simple way of understanding. Green, green, orange, orange, pair 1, blue. This one is the same. All right, this one is the same. This one is exchanged. Okay, the simplest way to understand this one, you just follow the color codes. So for straight through, this pair is twisted together. Then for this one, 3 and 6, twisted together. This one twisted together. This is the pair number 4. I think this makes for easy explanation if you're actually making the cables. You just follow the colors. You just follow the colors. Then for this B, these are the colors that you're going to be using: green and green, blue and blue. Then that is brown for pair 4. Ethernet straight through applications. How it's made. Both ends are T568A or T568B. So both ends is either, if you're using this standard, this end A and this end B, no chance this type of connection. Right? If you are using the Ethernet crossover, one end in a standard A, the other end in a standard B. What is the difference between straight through and crossover? If you want to connect, in today's technology, there is no difference between those cables because we have what we call auto MDX, auto negotiation. Is it auto? Yeah, auto MDX, which automatically detects the type of cable that you use. Kudara before this new technology report. Kana uri kuda connector a host to a network device. So for example, we have a switch here, another switch here, PC 1, 2, 3, 4. Kana uri kuda connect a host, this type of cable was straight through. So this is ST, this is ST, connecting a host to a networking device, ST. But connecting a switch to a switch or a router to a router, for example, this type of connection, Mupaga trace and something like this is dotted. This is the crossover cable. So Kudara, if you wanted to connect host to a device, you were supposed to use the Ethernet straight through. If you're connecting devices of the same type, you're supposed to use a crossover. But because of auto MDX, there is no need for that. So you see the type of cable which is commonly being used is now straight through, meaning even Panapapa, instead of using crossover, you can use straight through. Auto MDX automatically detects the type of cable that you are using and change my settings my devices so that it suits transmission inofanira kuitika pacable inenge yaiswa ipapo. This automatically or eliminates the need to worry about using the correct type of cable. So instead of worrying kuti ndoshandisa straight through here kana kuti crossover, it's no longer a problem. Solved by MDX. Then we have a cable rollover legacy. We no longer use this cable. I've never seen one myself. Legacy due to most NICs using auto MDX to sense cable type and complete connections. So the rollover cable is a Cisco proprietary cable. Inoshandiswa Cisco devices only. It's sort of the console cable of Cisco. It's a console cable, basically, which is used for those initial configurations. If you want to make initial configurations to a device, we discussed connecting the console cable. Cisco on cable yao yenza roll off. It also had the standard. I think my PSY, there's a way I my PSY. I don't remember, but I mix and up so that you can make the roll off. So you can see these three type of cables, the way they are made. I don't know my colors, Papa SR3, but my pairs sangana say you can see my pairs, they are very different. That difference do not define a type of cable yip. Let's look at that. But physical labs. Fiber. Izinto ezibaba ze-media izo. Hapana inosvika ipapapa. Fiber, the best. Hapana inosvika pa-fiber. Right, not as common as UTP because of the expense involved. The expense involved, not because fiber is expensive itself. It's not that expensive as compared to copper. Copper is expensive. I think the material itself, copper fiber. But the expenses that come with fiber is installation. So if we are talking overall cost, fiber can be expensive because of installation costs. You need engineers, number one, who know how to install that, how to install fiber, expertise. Muchada wanochera. Expertise, not that much expertise, right? It's expensive to install. Don't over expense. Fiber itself, per unit length, I don't think it's as expensive as copper, but the cost of installation, right? Ideal for some networking scenarios, transmits data over long distances at higher bandwidth than any other networking media, less susceptible to attenuation, and completely immune. That's a huge W there. Completely immune to electromagnetic interference. Made of flexible, extremely thin strands of pure glass, uses LED to encode bits as pulses of light. Fiber can act as a waveguide to transmit light between the two ends with minimal loss. To summarize all this, fiber is another form of media that uses light to transmit signal, to transmit a message. is very expensive to install, depending on scenarios. So for example, I'll give you this. Depending on scenarios, if I have a home office and my network in around 100 meters, the type of media that I'm definitely going to be using up, copper, it's cost effective. Kana ndine communication link rine 100 kilometers, for example, copper will probably not be cost effective. In terms of cost, if you're going to install in terms of cost, fiber will probably be cheaper over longer distances. So as you go through literature, you can come and discuss this. Prove me wrong. You can come and discuss this. Over short distances, copper is cheap. Over long distances, it's not as cheap because you need a lot of, for example, technology, because of attenuation. Over longer distances, there's a lot of attenuation. You need other devices so that you keep the power signal yako at optimum. Pamwe muchada ma-repeaters, muchada ma-amplifiers, muchada zvakawanda-wanda to add there. Over longer distances, the cost becomes expensive, not because of copper itself, but the additions that you can have to the link that you're going to design. Fiber, however, over short distances, it's expensive. Over those short distances, very expensive. But over longer distances, the longer distances, it's cost effective. I cannot say cheap, but it is cost effective, less expensive as compared to copper. Types of fiber media. The types of fiber media we have single mode, multi-mode. When we're talking of mode, the fiber uses light. There is light which travels in the core of the fiber. Can a light roll one root traveler? We call that type of fiber single mode. That light is the mode. When we have multiple modes, it means light akawanda. So you can visibly see from there, we have two lights. Remember, one is then another one is so. That's why it's called multi-mode. Now, talking of the structure. All right, let's look at the structure of fiber. I think it's very important. Structure of the fiber, it is made up of the core. This is the core. Then we have what we call the cladding. Fiber is something like this. So light rinopinda core umo. If I'm going to have a cross section, rinopinda core, this is our core right here. Light rinopinda and it moves like this. It bounces. That's how fiber works. With what we call total internal reflection. I think a whole lot of concepts that define, that's the physics. But bandwidth, it has a larger bandwidth because of the physics behind it. That's the physics. It's the paper. We have what we call total internal reflection. Because of that, fiber has large bandwidth. So in terms of the structure, what you need to know, and I think we will be assessed on that. Fiber in the core, domino light. Then in the cladding, it sort of acts as the boundary between the core. It sort of acts as the boundary between the core. Chinochenget is a light charge. All right. So if light can cladding in kuno. This is the cladding right there. Kuno cladding. Light are budem core because of the cladding. The cladding provides a boundary, this boundary, which allows light to core. Right. Dispersion refers to the spreading out of light. When we talk of dispersion, it's loss. Kukopa kuna attenuation, loss of power signal, attenuation. Kufiber, the biggest problem is dispersion. And dispersion, loss, because of multiple modes traveling in a fiber. So you see good multi-mode fiber suffer a lot of losses due to dispersion. Why we are learning this is so that you understand per application. Can you chance multi-mode fiber? Do not chance at minimum length, optimum length, short lanes afana okura sterek. You can see speed panapa is 10 gigabytes over 550 meters. Mukangopfura 550 meters yawai, this capacity inototanga decrease because of losses due to dispersion. But that is not a problem for single mode fiber. That's why for my applications are in a long distance panel, because it's not easily affected by dispersion. So dispersion in short is loss. And that loss yakawanda ku multi-mode fiber because in modes akawanda. Modes akawanda means more dispersion. In a mode 1, it means minimal dispersion. More dispersion means more losses. It means we cannot transmit over longer distances. For my applications, so can I a very small network, I'll go and take multi-mode fiber. You see it's cost effective. It's much cheaper. Even Pakutenga, this one is cheap. This one is a bit expensive, single mode. So can I do delay smaller distances, my links and smaller distances? I'll definitely go for multi-mode fiber because pays the bus. But for longer distances, this will no longer be cost effective. Because of my losses, we go and use single mode fiber. All right, cable handling. Optical fiber cabling is now being used in 4 types of industry: enterprise networks, the backbone, cabling applications, and interconnecting infrastructure devices. We have FTTH fiber to the home. Kana fiber kumba kwenyu is because of FTTH. That's a new technology which allows us to connect using fiber. Long haul networks, submarine cable networks. Fiber ndo yakabata networking yese, internet yese, via these submarine cables. Cables we won't have internet. Huge cables under the sea, which carries all the traffic in the internet, used over the internet. So these are some of the applications that we have for fiber. Our focus in this course, fiber within the enterprise. Okay, no big deal. All right, type of connectors. Cool, UTP, copper. I think the main type of connector I want is the RJ45. With fiber, we have the ST connectors. This one we no longer use that much. It's a legacy connector. ST connectors, they are used in older installations. We have the LC. This one is being used these days. It's very small. It's very compact. And it's widely used in many applications because of its compactness. In a high port density as well. Then we have the SC connectors. This one, I think this one is the most commonly used. This one, you definitely encounter one of these, the SC connectors. Very easy to connect. Reneka katinoti push latch, push and pull latch. Kasema hapo. Kana uchida connect unongosvika unokapusha. In fact, unongobatanidza. Very difficult to demonstrate. But let me just say, in a katinoti push and pull latch, which makes it very easy to connect. Mamwe, you can see with this one, connection, you probably need to twist and do whatever, twist and turn so that you can connect this connector. But with this one, when we come for the labs, hopefully demonstrations, that one was not easy explaining, but those are the type of connectors that we have. Then we have my patch cords. My patch cords, if you want to connect, let's say you have two my devices are very close. So for example, my cabinet, then a switch, right? My pause arrow, that's our switch. Then a switch, I want to connect these two devices using fiber, probably. A type of cable can I but not a patch cord. Patch cord. What is a patch cord? Right. Uh, These are fiber optic cables with connectors on both ends used to connect devices, switches, routers, servers. Pre-made, very small, usually very small. They are not that long, my page codes. And you can see they have different type of connectors. So you see, for this one, AC, my devices are my AC connectors. Then you have maybe imwe device rine ST connector, rimwe device rine LC connector. Ndo panowanzobuda the importance repage code up. So you are trying to connect two my devices and my different type of connectors. How do you connect them? You use a page code, for example, this one, and two different connectors at both ends. Page code, no big deal. Fiber versus copper. All right, a comparison of fiber and copper, 2 minutes. Right, a comparison of fiber and copper. I think during this session, I've explained quite a number of comparisons. Bandwidth, the physics behind fiber means it has more bandwidth. You can see copper going at 10 megabytes to 10 gig. This one can go up to 100 gig. It's because of the physics. For now, I think it's good enough. The physics behind fiber optic cabling, it has more bandwidth. Distance, fiber can go for longer distances. Why? My losses are there minimal. No electromagnetic interference. That's huge. It means longer distance the transmission. Immunity to AMI. This one is very high because of the physics. Immunity to high physics. Median connector costs. This one is a bit expensive. Installation skills. This one is a bit expensive. If you're choosing career-wise, you can be an optical fiber technician. Why? Because installation skills, they are very high. You get paid for that. Safety precautions, these are the highest. I have a question mark here. Safety precautions. Dealing with copper, dealing with, okay, a little research. Why safety precautions are high here and low here. I cannot explain that. Because in my head, I would think copper could be much higher. All right. I think one last session can finish, even half session. I think 15 minutes would be enough to finish wireless media. Join me soon after. I'm stopping this one.